Hello all. In this video I am going to demonstrate flame detection or fire detection using an infrared LED. As you can see here, I am having a flame facing in front of the infrared LED. So this is my infrared LED and this is the amplifier circuit, operational amplifier circuit. Presently I am getting 1.4 volts at the output of the operational amplifier circuit, and this voltage is fed to Arduino Uno. And this is the Arduino Uno, and you can see this is the flame count and the flame percentage. 273 is the flame count and 24% is the flame percentage. As you can see here, this is the flame, and now if I bring the flame closer, you can see the intensity will increase. As you can see, the intensity is increasing, the flame is coming close. Now the candle is finished, that's why the sensor is not able to detect the flame properly. If I bring the flame little far and tilt the sensor a little facing the flame, still it is facing problems to detect the flame. However, if I bring the flame closer to the sensor, you can see it is still detecting. If I make an angle to the LED, you can see now it is reading a very good flame because of the angle, because of the line of sight. It is having problems with the line of sight. Now as you can see here, I am reading the flame, some 3 volts on the LED on the multimeter I am getting. So here you can see this is the 63% of the flame. The flame count is, this is the 61%, and the flame count is 493. 602. So like this I am going to measure the flame. So as you can see here, if I destabilize the flame, I am destabilizing the flame, you can see the voltage is changing. You can see the voltage is changing and the flame intensity will also change, because the infrared LED is detecting a difference in the flame, and that is being reflected on the output of the circuit. So now I am going to explain the circuit little. I will bring the flame little forward. The candle has exhausted. It is having difficulty to detect the flame. So now, and the flame is very small. You can see the flame is very short flame, very little flame. With that also, it is detecting 23% of the flame count. The sensitivity is very good in this device. So now I am going to explain the working principle of the circuit. So as you can see, this is the infrared LED, and this is the 220 ohms resistor in series with the infrared LED, and this is the 330 ohms current limiting resistor to the whole loop. The voltage across this 220 ohms resistor is fed to the operational amplifier. The operational amplifier is connected in differential amplifier mode. The output of the differential amplifier is fed to the unity gain buffer. Finally, the output of the unity gain buffer is fed to the Arduino Uno analog input channel here. And finally, the Arduino Uno is processing the data and it is displaying on the LCD display. As you can see, the flame is continuously reducing and the voltage also is reducing. You can see it was 1 volt, it is gradually reducing. Now I am going to show the theory of operation of the circuit. As you can see, this is the circuit diagram. And on the circuit diagram you can see this is the IR LED. We need to notice that the IR LED is connected in reverse biased condition. This IR LED is connected to reverse bias mode, and it is supplied with 12 volts DC supply. I forgot to add a resistance here, current limiting resistance. I will add it now. So this resistance I added in the circuit but forgot to draw in the diagram. So this is the current limiting resistor. Whenever there is a flame detected, there will be a voltage difference across this 220 ohms. This will be amplified by the unity gain buffer here to a factor of 10. 10k divided by 1k to a factor of 10, which will be given to the unity gain buffer. This is a impedance matching op amp. And finally, I will be giving this to the Arduino Uno input. This is how the circuit is working. This is the working principle of the circuit. As you can see here, the flame is constantly reducing. You can see the flame count is getting down. So this is how the circuit is working. Thanks a lot. Thanks for watching.